All right, so when you are deciding if it's independent or mutually exclusive or overlap, the first thing you want to consider is how many things are happening. If only one thing is going to happen, you're going to spin one dice. You're going to pick one shirt. Then it's got to be mutually exclusive or overlap. If multiple things are happening, you're spinning a spinner and flipping a coin, okay? That's independent. You're picking a jersey and then you're rolling a die. If 2 events are happening, then it's independent. If 3 events are happening, then it's independent, all right? If more than one thing is happening, it's independent. If only one thing is happening, then we gotta consider mutually exclusive overlap. Then you gotta ask yourself, does the outcome from event A share anything in common with the outcomes of event B? If the answer is yes, then it's overlap, okay? If the answer is no, then it's mutually exclusive. So, the first problem says, a spinner has an equal chance of landing on its 8 numbered sections. After spinning, it lands in region 3 or 6. How many times are you spinning? Once. After spinning, it doesn't say after spinning 2 times, it just says after spinning, all right? So I'm spinning 1 time. It's not independent. That means it's either mutually exclusive or overlap. So let's think about what the outcomes are. Outcome A is it lands on region 3. And outcome B is it lands on region 6. In one spin, can it land on both 3 and 6 at the same time? No. Then that means it's mutually exclusive. If the answer is yes, one spin's going to get me both of these things, then we'd say overlap, okay? So this first one is mutually exclusive. Now, you didn't have to do the probability. We're going to do that together, though, okay? So once you decide something is mutually exclusive, the mutually exclusive formula is this one, probability of A plus probability of B. In this case, it would be probability of spinning a 3 plus the probability of spinning a 6. Keep in mind that this is an 8-sided spinner. All right, so there's our spinner. If I spin that spinner, what are the chances that it lands on a 3? 1 out of 8. There's 1 3 on the spinner out of 8 total sections, so we'll say 1/8. In a separate spin, if I spin that spinner, what's the probability it lands on a 6? 1 out of 8. So the mutually exclusive probability would be adding those 2 things together. All right, there are a few ways that you can actually do that. You can put parentheses in your calculator and then math enter them. If you have the alpha y equals tool where you can make your fractions look like fractions, you don't have to math enter. The calculator automatically simplifies them. If you're going to do it by hand, when you add fractions, you add the top numbers, but you keep the bottom numbers the same. And then you always have to check if that simplifies. Okay, all of these give me the same answer. The final answer to this problem is 1/4. Right? If I were to circle the numbers 3 and 6, I am circling 1/4 of the board. All right? Next one. A bag contains 6 yellow jerseys numbered 1 to 6. The bag also contains 4 purple jerseys numbered 1 to 4. You randomly pick a jersey. It is purple or has a number greater than 5. How many jerseys are you picking? 1. You randomly pick a jersey. It's not independent then, okay? So now I'm thinking to myself, okay, well, it's mutually exclusive or overlap. So let me think about, is it possible for me to randomly pick up a jersey that is purple and also contains a number greater than 5? Well, think about what we know. We have 6 yellow jerseys, 1 to 6. So we'll call this yellow 1, yellow 2, yellow 3, yellow 4, yellow 5, yellow 6. And we have 4 purple jerseys, 1 to 4. Purple 1, purple 2, purple 3, purple 4. if I were to circle all of the purple jerseys in pink and all of the numbers greater than 5 in black, did I double circle anything? There are no jerseys that are purple that also have a number greater than 5 on them, right? Not in this instance at least, okay? So because of that, these are mutually exclusive. Overlap would be, okay, I have purple jerseys numbered 1 through 10, and now I have a purple jersey greater than 5, right? But because it's only 1 through 4, then this is mutually exclusive. So the probability of mutually exclusive events would be the probability of purple plus the probability that I have a jersey greater than 5, all right? So there are 10 total jerseys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of those 10 purple jerseys, or sorry, of those 10 jerseys, 1, 2, 3, 4 of them are purple. Plus, of those 10 jerseys, only one of them has a number greater than 5 on it. It's the yellow number 6. And so I'm gonna do 4 tenths plus 1 tenth. You can do it any of the ways. Ultimately, your answer ends up being 1/2. I circled half of the numbers when I circled up there. I could totally see how that one might appear to be overlapping, because it's definitely possible to have a purple jersey greater than 5, right? But in this case, we didn't have that, just because of the numbers that they were given. All right, next one says, a magazine contains 12 pages. You open to a random page. A random page, one page. It's not independent, all right? The page is an 8 or a 10. Can I, at the same time, open to page 8 and 10 if I'm only picking one page? No. This is a mutually exclusive one as well. So I'm going to take the probability of opening to page 8, and I'm going to add it to the probability of opening to page 10. Keep in mind there are 12 pages. Of those 12 pages, how many of them are page 8? 1 out of 12. Of those 12 pages, how many of them are page 12? 10. Sorry, how many of them are page 10? 1 out of 12. I'm circling 2 out of 12 numbers. And that fraction reduces to 1/6 when we calculate that. All right, this one's a little tricky. It says a box of chocolates contains 6 milk chocolates and 4 dark chocolates. 2 of the milk chocolates and 3 of the dark chocolates have peanuts inside. You randomly select and eat a chocolate. It is milk chocolate or has no peanuts inside. So first of all, you're picking one chocolate. All right, so it's not independent. All right, but let's think about what we have. We've got 6 milk chocolates. 1, 2, 3, 4, 5, 6. 6 milk chocolates. You have 4 dark chocolates. Of the 6 milk chocolates, 2 of them have peanuts, and 3 of the dark chocolates have peanuts. So I'm going to do a P for the 2 that have peanuts, and a P for the 3 that have peanuts. All right, so a total of 10 chocolates. This is what we've got. Is it possible for me to randomly pick something that is milk chocolate and has no peanuts at the same time? Is there a chocolate up there that's milk chocolate with no peanuts? Yes. Okay, this is an overlap. To calculate an overlapping probability, we're going to take the probability of event A. Probability of event A would be it is milk chocolate. Okay? So there is 1 2, 3, 4, 5, 6 milk chocolates out of the total of 10. Plus the probability of no peanuts. So I'm going to circle the ones that have no P, right? Because the P stands for peanuts. So this has no peanuts. 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 So the second probability of MP is no peanuts, and that's the pink. And I'm showing 1, 2, 3, 4, 5 out of the 10 have no peanuts. Now, if you didn't treat this as overlap, you would end up with 11 out of 10, which is literally impossible. So hopefully then you'd realize, okay, well, then I probably have to subtract something. What do I have to subtract? Well, the repeats. How many are milk chocolate with no peanuts? I circled that twice. I circled that twice. I circled that twice. And I circled that twice. 4 out of 10 is the overlap. So I would subtract that. All right. So overall, we end up with 7 out of 10. That's my final probability. Which makes sense because look, I listed out everything we had. How many did I circle? 1, 2, 3, 4, 5, 6, 7 out of the 10. You okay with that one? Overlap is the hardest one in my opinion. You gotta really think about what you have. All right, number 5. You flip a coin and then roll a fair 6-sided die. How many things are you doing? 2. You're flipping a coin. You're doing a die, right? So 2 things. So if you're doing 2 things, this is going to be an independent probability. Anytime it's more than one event. Independent probability says that I'm going to multiply the 2 events together. So for the first event, I'm going to find the probability of the heads, and I'm going to multiply that by the probability of getting an even number on the dice, right? So the probability of getting a heads on a coin is 1/2, and the probability of getting an even number on the dice is 3/6. You could also write that as 1/2. 3/6 and 1/2 are the same thing. When you do the math, you want to just make sure you do a math enter, and reduce the fraction, because it should end up being 1/4. Your calculator will do the math part for you. You just have to know how to type it in. You roll a fair 6-sided die twice. How many times are you rolling? Twice. Anytime you're doing more than one thing, that's independent. So I'm going to find the probability that I get a 5 on the dice, and I'm going to multiply that by the probability that I get a 6 on the dice. 1 out of 6 parts of the die are a 5, times 1 out of the 6th part of the die are 6. The chances of that happening is 1 out of 36. What are we doing? Okay. All right, so today I'm going to have you do some practice so that hopefully by the end of the class I can calculate probability of independent events, I can calculate probability of mutually exclusive events, I can calculate probability of overlapping events. All right, I want you to be able to do all of those things, and you're going to do it in groups. All right, so I'm going to have you come up here. I'm going to have you slide there, and you can pick. Bring a desk, and actually you can pick, but you can't pick that group. They already have 5. And you can't pick that group, because they already have 5. We gotta pick okay, so you're going to do page 23 in your groups of 4 or 5. All right, they're strength in numbers. Ask friends for help. Ask non-friends for help. We're not talking about the weekend, right? We're talking about probability. Easier. Yep. Yep. I want you to put a pass in the kiosk for A19. Mr. Bailey. room, but if you want to check in with them, make sure you're doing it right, or if you have questions, that's what your group members are for. We are going to skip 12 and 13. Over the years, I have become increasingly exhausted explaining what a deck of cards looks like. And so I've called it quits. And I'm no longer doing decks of cards. So cross off 12 and 13. We're not doing them, all right? So, you're doing page 23. I'm going to post the solutions towards the end of class so that we can go over the descriptions together and answer any questions together, all right? I have a graphic organizer of the events here, but I also have them on the backboard too. So if you're closer to the backboard, use the same things on the backboard. I don't think so. All right, let's do it. All right, so the first one says, an article contains 14 pages. You open a page at random. You open a page at random. Find the probability that the page you open to is 5 or 7. You're opening a single page, meaning it's not independent. So now I'm asking myself, is it mutually exclusive or overlap? And to answer that question, it's can I open one page and it be both 5 and 7 at the same time? No. So this is a pair of mutually exclusive events. All right? To find the probability, I have to think about what I know, right? I've got 14 pages. How many of those pages are page 5? 1 out of 14. How many of those pages are page 7? 1 out of 14. To calculate a mutually exclusive probability, you just add those two probabilities together. So the answer to this one is 1/7. 1/14 plus 1/14 is 2/14, which is 1/7. A basket contains 3 apples, 3 peaches, and 4 pears. That is 10 total things of fruit. All right, 10 is your total. Find the probability of randomly selecting a peach or an apple. Those are both singular, right? I am doing one pick. It's not independent. So now I'm asking myself, in one single pick, can I do both of those things? Can I pull one piece of fruit out and it's a peach and an apple at the same time? No. All right, so this is mutually exclusive as well. So I'm going to find the probability of getting a peach. That's 3 out of the 10. The probability of an apple, that's 3 out of the 10. And mutually exclusive probabilities just get added together. So I'm doing 3/10 plus 3/10. That ends up reducing to 3/5. The final answer to this one is 3/5. Questions on 6 or 7? All right, let's look at number 8. There are 8 shirts in your closet, 4 blue and 4 green, 8 total shirts. You randomly select one to wear on Monday and then a different one to wear on Tuesday. How many shirts are you picking? 2. If you are doing more than one thing, it is going to be independent probability. So to calculate the probability here, I need to find the probability that I pick a blue shirt on the first day. That's 4 out of 8, or 1/2. And then it says you're putting it back, right? So the probability of getting blue on the second day, 4 out of 8, 1/2. Independent means take those two things and multiply them. 1/2 times 1/2 is 1/4. The answer to this one was 1/4. Questions on number 8? All right, number 9. A box contains 3 red playing cards, numbered 1 through 3, and 5 black playing cards, numbered 1 to 5. You have 8 cards there, right? 1 to 3, 1 to 5. That's 8 cards. You randomly pick a playing card. That is singular. It is not independent. It's either going to be mutually exclusive or overlap. So I got to ask myself, if I pick one card, can it be black and have an odd number on it? Yeah, right? There's black cards that are 1 through 5. There's odd numbers in that combination. So this is overlapping probability. So I'm going to take the probability of having a black card. There's 5 black cards out of 8. plus the probability of getting an odd card regardless of color, right? So there's a red 1, a red 3, a black 1, a black 3, and a black 5. That's 5 out of 8. And then I'm going to subtract the black cards that are odd at the same time. So I underlined black 1, black 3, and black 5 twice. All right, so 3 numbers are both black and odd. So that's my overlap. So overlapping probability is A plus B minus A and B. So I'm going to do 5/8 plus 5/8 minus 3/8. This answer is 7/8. All of the cards are either black or odd except for one of them. What card is not black or odd? What is it? Someone's at it. Red 2, right? Red 2 is not black because it's red, and it's not odd because 2 is even. So that's the 1/8 that's not showing up here. All the rest are one of the 2. All right? A bag contains 10 yellow jerseys, 1 through 10, and 8 blue jerseys, 1 through 8. Find the probability that you randomly select a jersey, 1, and it's blue or greater than 4. So 1 jersey, it's not independent. I have to ask myself, is there a such jersey that is blue and has a number greater than 4 on it? And the answer is yeah, there's a few of them. So this is an overlap. To calculate this probability, I'm going to first find the blue jerseys. There are 8 jerseys that are blue out of a total of 18. Then I'm going to find my greater than 4s. This is regardless of color. So I've got yellow 5, yellow 6, yellow 7, yellow 8, yellow 9, yellow 10, blue 5, blue 6, blue 7, blue 8. All of those are greater than 4. 10 out of 18 jerseys. What I'm subtracting is the blues that are also greater than 4. 1, 2, 3, 4 of them is my repeat, right? The one that meets both criteria. So the formula is event A, which is blue, plus event B, which is greater than 4, minus the blues that are greater than 4. 7/9 is the final answer for that one. Overlapping is definitely the hardest. All right. A cooler contains 10 bottles of sports drinks, 4 lemon lime, 3 orange, 3 fruit punch. 3 times you randomly grab a bottle. 3 times. Independent. Multiple events are happening. To calculate independent probability, you're just going to multiply the probability. So I'm going to do the probability of lemon lime, 4 out of the 10, times the probability of fruit punch, 3 out of the 10, times the probability of the fruit punch, 3 out of 10. It's a weird fraction. You're used to doing 2 events. This was 3, so it's a third fraction added into the mix. You can type that in your calculator to get that answer, though. And then the last one, we've got a basket with 5 apples and 7 peaches. All right, total of 12 things. You randomly pick 1 piece of fruit and put it back, and then you pick another one. You're picking 2 pieces of fruit. This is independent. You're doing more than one thing. So you're going to find the probability of an apple, which is 5 out of 12, and you're going to multiply it by the peach, which is 7 out of 12. 35 out of 144 is the answer. All right, so we are done. Well, not done yet. Hold on. We're almost done yet. But tomorrow will be the last new day of the unit. Your test is not until next Thursday, over a week from now. You have a long weekend and you have a freshman class trip. So what we'll do is I'll teach you the new stuff tomorrow, and then we'll have a practice day on Thursday and a review day the Wednesday after your trip, I think, right? Yes. And then your test will be that Thursday, all right? For tonight, you do have a homework assignment on Canvas. There's 5 of the same type of problems that we just did. I tried to copy and paste visuals on there so you could see what you're looking at. Like if there were jerseys, I have pictures of the jerseys, okay? So you can use the visuals. If there's spinners, there's pictures of spinners. The coins are on there. All of that's on there. There's 5 of them. You have 3 attempts. it will automatically populate in PowerSchool overnight. So if you do it, it'll populate. If you don't do it, it's going to be a 0 overnight. All right? You have 12 minutes now, or you can do it tonight. It's due at 11:59.